on methodology. This will be covering the brute force method. Brute force is a fallback method. You can always use it, but is the method that you should stay away from, since it is very error prone, and it's error prone in ways that makes it so you can't necessarily detect it. It'll have further problems too if you start getting rather large calculation problems, and I'll hit some of those issues as we get to a final solution. Essentially what you're doing with brute force is treating each one of the elements that we have here in our benefit series as if it was a singleton, bringing it forward in time or backward in time all by itself, and then adding the results all together again. So let's go ahead and start with calculating a future value, which you should think of as the amount of money that you'll have in the bank at the end of the period, in which case it's period 5. Here we have our constant series. You're receiving $10 every single period for periods 1 through 5. And key here is that nothing is happening in period 0 as part of the definition of a constant series. It's easiest to start with thinking about this in period 5, and that you have a deposit going on in period 5, but as you're valuing it in period 5, it doesn't get to earn any interest for you. In order to, what you'll have in the bank after you deposit $10 in the last period is simply $10. But that deposit that you made in time period 4 gets to sit in the bank for one period, and it will earn you a little bit of interest. So if you deposit that $10 in the bank in time period 4, it grows up to be $11 once it gets to time period 5. Now, similarly, working back in time, you can see that the deposit you made in time period 1 gets to grow all the way up to time period 5. And I'll go ahead and fill in those equations now. Now, what we have here is simply an equation which takes the amount of money that you deposit right there, multiplies it by 1 plus the interest rate raised to the number of periods remaining. So the idea is that when you deposit $10 in period 1, by the time it reaches period 5, it'll be worth $14.64. The deposit in period 2 would be worth $13.31, so on down the line. But this is all predicated on that account earning you 10% per time period. In order to find out how much you'll have in the bank altogether, all you have to do is add these guys up. You find out what the future value is. Again, future value interpreted as the amount of money that you have in the bank at the end of the time period, which in this case is going to be 5. Now, present value is very similar, but you should think of this as the amount of money that you'd have to deposit in time period 0 to fund all these withdrawals. So instead of bringing all the money to time period 5, you're effectively bringing it all the way back to time period 0. So, in order to do this, the logic is quite similar. What you're doing is taking the amount that you deposit and then saying, well, how much do I have to deposit in time period 0 in order to fund this particular withdrawal? And what you see is you need to deposit $9.09 in time period 0 to make it so that you can draw $10 in time period 1. Now, similar values will be hanging out here, and I'll go ahead and fill those in. So I've filled them in, and the equation you're looking at is just that P is equal to F on 1 plus I to the n. Here is the amount that you're depositing, that $10 right there. Here's 1 plus the interest rate. This is always refers to the interest rate. And then this is the number of periods that you have to take things back. This refers back to the 5 that's right there. In order to find out what you have to deposit in the account to fund all these flows, all we have to do is, again, add them up, just as we did in the future value case. And so it turns out to be $37.90 will actually fund all these flows. Now, you can go backwards and forward from present value to future value. You don't have to make all these really rude calculations. So you could, for example, take just this future value that's right here. And remember, that's something that's in time period 5. And you can take that value that's in time period 5 and move it back to time period 0 with that simple kind of discounting that you've dealt with before. You see that we end up with exactly the same number. That's part of the reason why we're using this exponential discounting. It allows all this interesting kind of additive separability that is easy to cope with. Now, while this is simple and you can apply it everywhere, it can be extremely dangerous. Picture trying to do this for a really, really long series. Try to think about doing it for a mortgage, 360 payments. It's not the kind of thing you can do on the calculator. It's the kind of thing you can do on a spreadsheet. But it's also the kind of thing where if you're not careful, you can end up with an awful lot of rounding and truncation error, which is part of the reason why we're going to be moving on to equations in the next step. But in the meantime, keep an eye on these two answers right here, $61.55 for the future value, how much you'll have in the account in time period 5, and $37.90, which is the amount of money you need to deposit in time period 0 in order to fund the stream of benefits, because they're going to be showing up again.